back to DIY Builds in the great state of Texas. My name is Phil, your host, and Duke is asleep in the room, so I'll tell him everybody said hi. I got a couple things going on today. What I'm going to do as part one is I'm going to give you a Mega Boombox update, show you what I've gotten done so far. This project is going a lot slower than I expected because there's just so many components and aspects to this build, and I don't have a lot of time because I've been working about 60 hours a week, so the weekend is the only time I can get a few hours to actually work on it, and this box is going to take at least 20 to 30 hours worth of work. I mean, the wiring alone is going to be at least 7 or 8 hours. So anyway, let me change the camera position here. I'm going to show you on the inside how things are laying out. And after we do that, we're going to talk about power supplies for a couple of minutes and give you guys an update on that. And we'll go from there. So you guys have a great, I guess I'm not signing off yet. I've had a long week. I really have. Anyway, guys, give me just a minute. I'll move the camera and I'll show you what's going on the inside. So be right back. Okay, everybody, I've got the camera in my hand now. And let me show you what's been going on over here. As you can see, I've got some switches installed across the top here. That's going to be for the different components. And I've got the trim piece painted real nice. And I've got the 12-volt socket meter USB port installed. And let me show you what's going on the inside. It's really busy here in this box. Move the light a little bit so it's not shining so much. Okay, you can see the amplifiers right there, and what I'm actually planning on doing is mounting the amp sideways like that and furring it out just a little bit, and then try to put some insulation down here. I gotta be careful because it's gonna hit the speaker right here if I'm not careful. And of course you can see I originally wanted the battery sitting here, but as you can see I had to move the battery over here, and the other batteries over here by the base tube, and of course the power supply. It's going to sit here underneath the radio. And this is the voltage booster that I have here. And I'm going to mount it up on the wall with some straps a little bit. And I'm not sure about the relay yet. I'm not sure if I'm going to put the relay down here, or if I'm going to put the relay here on the wall. I'm not 100% sure yet because the voltage booster is going to be up here on the wall, because you can see this big old heat sink. I want to get that off the ground about right here, and also want it close to the base tube so some air can get through there. So that's what's going on with this, you guys. You can see it's really complicated. You can see all the connectors right there for the switches. I've got to run the wires down this way and down this way, hook all the wires up for everything. So as you can see, I've got my work cut out for me. So anyway, let me pause this for a minute, and we'll get back on the subject that I wanted to cover. So be right back. Okay, ladies and gentlemen, I'm going to do two things here. We're going to talk about power supplies, and I'm going to do a quick little talk about relays. I've been getting a lot of questions about relays. So, and this is kind of related to power supplies anyway, so I'm going to talk about that in just a couple of minutes. Alright, now, power supplies are great. What they basically do is they take the 110 volts that you have coming out of your socket if you live in North America and converts it down to 12 volts DC, is what your car stereo and your amplifier and things like that like to run on. Now, power supplies are interesting. Now, let me preference this by saying this. I know there's a lot of guys out there that are taking power supplies out of computers and using those to run their projects, and there's absolutely nothing wrong with that. That's something I just prefer not to do. I kind of prefer the regulated power supplies. They are a little bit more money, but they're more stable, and you don't have all the extra wiring to go through. So if you guys decide you want to use a power supply of an old computer, that's fine. And there's many videos on YouTube showing you how to do that. I'm not going to be showing you that today. What I'm going to be showing you is two different types of power supplies. There's an external power supply and a power supply that can be used internal. So we're going to start with this one right here. This is a Pyramid external DC power supply. Now this is great for testing car radios. If you just want to run a car radio, it puts out about 5 amps It's got two terminals right here to hook your wires onto. So you can got a cigarette lighter socket or 12-volt socket. You can just plug in your wire right there. And they work really fantastic. This one here actually runs my toolbox radio, the metal one if you've seen it before. I actually have a couple of terminals on the back of the radio where the power supply plugs in. And these are great if you just want to run your car radio in the house and have some sort of a setup with no batteries. And this would work absolutely perfect. So that's what these are good for. And these are very inexpensive. I think this one's $27. Normally, now they got some heft to them, and they have that industrial look. But that's what they're for. They're great for bench testing. If you want to bench test some radios or some components or things like that before you actually put it in your car or your setup, these are fantastic. So that being said, let me show you my Midwell power supply. Let me move this one out of the way here. Now this one's a little bit more complicated. This one here you got to do a little bit more work to. You are going to hook up your own wires to it. You see right here you've got the line, which is the positive, or the hot wire coming, the negative, and then you have your ground. These are your inputs here from your 120 volts. And then over here on this one, you have a positive side, negative, and a positive side and negative side. DC, the voltage is adjustable. Right here, I think it goes up to 14 or 15 volts. And it also says 29 amps here. So this thing here would be great if you want to run an amplifier, a larger car radio, or some of the components. This will do it absolutely perfect. And now the thing is, I've seen a lot of these online on YouTube. If you buy the cheap ones, they're going to burn out on you, and that's not what you want. You want to spend the money on a good brand. This is the Meanwell power supply. They're $50. They're well worth the money, and the nice thing about these is you can put them inside your project and hide them. Just make sure you get some sort of a plug. You can plug in the back of your radio, or maybe you can put an extension cord on it, or however you decide to design your system. But they work really, really great. But the thing is, if you're going to have this and batteries in the same thing, you're going to have to use a relay or some sort of a switch, because the power supply and the batteries have to stay separate, even though they're both powering your car radio. The reason is this is not a battery charger, and let me repeat that. Power supplies are not battery chargers. They're not designed for that. They're not designed for that kind of a load. The circuitry is not designed for that. Battery chargers are designed in a certain way to charge the batteries, and they have circuitry to cut off after the battery is charged. These are not designed to do that. These are designed to give constant power, and because of that, your batteries will overcharge, and they can ruin your batteries. The power supply can also overheat, and you can destroy your power supply as well. So the way you keep that from happening, and you'll see my other video about the relay, is you can use this relay right here. Now the cool thing about the relay is it has terminals that will allow the battery power to come through normally. But when the power supply comes on, it'll trip the relay. And when the relay is tripped, it will disconnect the batteries from the circuit and allow the power supply to come through going to your radio. Now let me show you exactly how this works. So what I'm going to do is try to move the camera a little bit, where I did a little diagram here that I can explain everything. So give me just a minute, and I'm going to do my best to explain how to hook up a relay. So I'll be right back. Okay everybody, I'm going to show you how to hook up a 14-pin relay, just like this one that you see right here. Okay, now this is how I'm doing my circuit in the Mega Boombox, and I'm hoping this will help explain it a little better. So in this diagram here, we have our 12-volt battery right here. We also have our power supply, and over here we have a radio, or you could have an amplifier, whatever you would like to have. As you can see, the relay has pins numbering 1 through 14. Now, the pins 1, 2, 3, and 4 are what we call normally open. Normally closed. And what that means is, if you hook up the battery through the relay over to the radio, the power will flow through with no problem. Now we have over here terminals 5, 6, 7, and 8. They're what we call normally open. And what that means is the power supply, if it was on, power cannot go through the relay because it's blocked. These switches are off, basically. Normally open is another way of saying they're off. Normally closed means that they're on. Now 9, 10, 11, 12 over here are what's called your common terminals. And what that means is this is where the power is coming out from the relay and going to your component. Now 13 and 14 are your positive and your negative terminals. And what that's going to do is that's going to activate the relay and turn the relay on or off when power is supplied through here from a constant source. In this case, it's going to be the power supply. So what's going to happen normally is you have your common wires over here. So right now the power is going from 1 to 9 and from 2 to 10 straight through the switch, because this is on right now as it sits. The relay is turned off, so power is allowed to flow from the battery to the radio through the common terminals. Now what's going to happen is when the power supply is turned on, power is going to come from the power supply into the relay. When that does that, the relay is going to turn on, or it's going to switch. A relay is an electric switch. When the relay switches, what's going to happen, it's going to turn off terminals 1 and 2 and turn on terminals 5 and 6. So now power is coming from the power supply through the relay into the radio. The battery has been disconnected because this switch has been turned off. So as long as we have power constantly flowing to the relay from the power supply, 1 and 2 will be turned off and 5 and 6 will be turned on. Now what happens is, when you turn off the power supply, what's going to happen is, since power is no longer supplied to the relay has a spring inside that's going to switch back. So now 5 and 6 will be turned off. So power can no longer flow through 5 and 6. 1 and 2 will be turned back on. And what that's going to now allow is the power from the battery to go to the radio. Now the radio doesn't care where it gets its power. It's happy getting power from the battery or power from the power supply. But as you can see here, the relay is like the gatekeeper. It only allows, like a traffic cop. And sometimes it'll allow power from the power supply to go to the radio, or sometimes it'll allow power from the battery to go through. Think of it kind of like a traffic light. When the traffic light is green for the battery, the power supply has a red light. So the power supply can't go through the intersection. This is like an intersection. But the battery can go through the intersection, make a right turn, and go to the radio, which is its destination. Now, when the power supply turns on and trips the relay, now the light changes in a sense. So now the power supply has a green light to go on through the intersection to its destination. And now the battery has a red light, so the power is stopped from coming in from the battery. And as you can see, the power supply and the battery will never touch each other, but they're still supplying voltage to the battery. And the battery doesn't know the difference. Now, as you can notice over here, I have a switch, and that's going to the red wire on the radio. What that is for is, on the radio, the yellow wire needs constant power. That's what holds your memory, and that's what powers the radio on modern radios. But the red wire is kind of like the ignition in your car. You don't want the radio on when the car is off. So by putting a switch here, even though power is on constantly, you can control whether the radio turns on or off with this switch. Now I also have a switch here between the positive side of the power supply going to terminal 14. And the reason I do that is because when you turn the power on, it instantly goes to the relay and trips the relay. But the problem is, when you turn the power off on the power supply, what happens is the power supply takes a couple of seconds to decharge. even though so it takes a few seconds for the relay to trip. Well, what will happen is there's no power coming in from the power supply. The relay hasn't tripped yet, so now the radio has no power at all because the batteries haven't come back online until the relay trips back. So what happens is you're going to lose the memory on your radio. Now, if you don't care, that's fine. You don't have to worry about it. But if you put a switch on here, you leave the power supply in the on position and flip the switch. When you flip the switch, that cuts the power to the relay. Instantaneously, the relay will switch from the power supply back to the battery, and the radio doesn't know the difference. The radio doesn't care. The radio just wants power. Then you can come over here and turn off your power supply manually, and everything will work just fine. And it's just the reverse when you want to turn it on. Turn your power supply on first, and then you can go ahead and flip the switch, disconnecting the batteries and allowing power supply power to go through to the radio. Anyway, ladies and gentlemen, I hope that explains it. The reason I did this because I had a bunch of questions from a couple of people about relays, and they really didn't understand how they works. I really hope this helps. I'm trying to explain it the best way I possibly can. I know it's a little tricky. This is advanced electronics, but I'm trying to break it down in its simplest form. So, anyway, guys, thanks for watching. If you have any questions, please ask me on the comments or on I Love All Things Radio. That's my Facebook page. I'm going to try to put it right here on the screen if I remember to this time. And thanks for watching, guys. And we'll have another video next week. And hopefully we'll be getting this Mega Boombox done in the next few weeks. It's just taking a lot longer than I thought. So have a wonderful day, guys. And we'll see you next time.